Hey guys, this is Miss Lockhart. I just wanted to give you a quick demo on how to do your homework. So your homework is all about pH calculations. So pH literally means concentration of hydrogen. It comes from the French word, however you say this. You can ask Mr. Manellis later. And it means hydrogen power. So the definition of pH is equal to the negative log of the hydrogen ion concentration of a solution. The logarithm of a number is the power to which 10 must be raised to equal that number. So if you've covered logs in algebra, this should be super easy. If not, I'm going to teach you how to use your calculator to do it. So a pH value of less than 7 indicates an acidic solution. A pH value of 7 indicates a neutral solution. A pH value of more than 7 indicates a basic or alkaline solution. All right, so for these questions, you'll notice that it's asking you not to find so in these questions, it doesn't tell you what the concentration of hydrogen is. It's telling you the concentration of an acid, but we need to know hydrogen. So that brings up a question of what happens when I dissolve this guy in water. Okay, so first of all, let's talk about some strong acids that we know of. So in our homework today, we're only using strong acids and strong bases because a strong acid in water, let me get some blank paper. All right, so strong acids in water, you can imagine it's a hydrogen attached to some big chunk of molecule, so some kind of anion. So for instance, we can have H attached to chlorine or H attached to iodine. So it's hydrogen, a positive particle attached to some negative particle, and that's an acid, okay? Well, when I dissolve those in water, remember that water is going to separate them apart because these are connected with an ionic bond. So when it separates them apart, I get H plus in solution and a minus. So this could be anything. The important thing to know is that the hydrogen splits off from the base. Now, in strong acids, that's going to happen almost 100%. I say almost because there's some amount of variability, but almost 100%, and it only happens with strong acids. So if we know that I have 1 mole of an acid over here, and I split it apart, then that means I'm going to have 1 hydrogen here and 1 part of the acid over here. So the negative or the conjugate base is over here. So if I have 1 hydrogen here, I have 1 here. So because of that, I know that 1 mole makes 1 mole of hydrogen and 1 mole of whatever this is over here. Because remember, moles are just counting numbers. So when I have a counting number, like let's say I have 6 of these over here, then when I split that apart, I'm going to have 6 hydrogen and 6 of my anion. So what that looks like is this. Picture this situation right here. So when I dissolve this in water, these are my hydrogens and these are my anions. Here I have 2 moles of this. Now, when they get dissolved in water, they're going to split apart to where I have this and this separated from this and this. So now I went from having 2 particles to 4 particles. However, how many white particles do I have? I have 2. So that means I have 2 moles of this, or 2 molecules of this. And how many of these? I have 2. So 2 molecules of the anion. So notice that my moles are conserved. My moles are not conserved. So I have 2 here, but I have 4 on this side. But remember, it's just a counting number. So I have 2 particles here. They separate apart and they make 4 particles. All right. So that brings us to the rest of the strong acids. So which strong acids behave this way? Because only strong acids will go through this process every time. And those strong acids are going to be pretty much anytime hydrogen is attached to a halogen except for fluorine. So that means when we have hydroidoic acid, hydrobromic acid, perchloric acid, HCl, hydrochloric acid, H2SO4, sulfuric acid, and when we have nitric acid, HNO3. So those are our main 7 strong acids that you need to know, and those are the ones that will have this happen 100% of the time. So what that means is that if I have 2 moles going in, then I have 2 hydrogens over here. Well, now I have the concentration that I need for my pH formula. So let's go back to our original problem. All right, so let's say that I'm going to dissolve 0.010 molar of HNO3 in a solution. So that means after I dissolve it, I'm going to get some amount of hydrogen plus some amount of nitride. All right? Sorry, nitrate, got my nomenclature right. Okay, so I have some amount of hydrogen and some amount of nitrate. Well, I know that if I had this many to begin with, then according to this model, 2 moles of this will make 2 moles when they split up and 2 moles of this when they split up. So that means I have 0.10 molar of hydrogen and 0.10 molar of nitrate. So now I can plug that in my formula, and my formula is pH plus POH equals 14, but I just need to know my pH, so pH is equal to the negative log of the concentration of hydrogen. So what that looks like is I just plug in my numbers. So it's equal to the negative log of, oh, I wrote it wrong, 0.01. 0.01 molar of H+. So I'm going to put that in my calculator. Here's how that looks, in case you're not sure. So what I'm going to put in my calculator is 0.01. Then I'm going to take the log of that, and I get -2. But this negative right here tells me that I need to take the negative of that. So that means my pH equals 2. And so pH equals 2. And there's my final answer. But what if I asked you to find the POH? Well, the POH is really simple. We're just going to take this number and plug it in over here. So now what I do is I could say 2 plus the POH equals 14 and solve for it. So -2 minus 2, we get 12. POH equals 12. All right, so let's hop down here and look at this one, because we all know that we don't see an acid here. That's a base, and this is one of our strong bases. Sodium hydroxide is a strong base that you need to know. So when this goes into solution, we're going to have some concentration of NaOH. In this case, it's 0.001. And when it goes into solution, it's going to create some amount of Na plus some amount of OH minus. Now, we know that OH is a polyatomic ion and it's going to stay stuck together. So when it comes out, if I have 0.001 moles going in the same way that I have 2 moles makes 2 moles of the white. So if I have 2 moles of the white to begin with, I end with 2 moles. If I have 2 moles of the dark to begin with, I end with 2 moles of the dark. So if I start with 0.001 moles of Na, I end with 0.001 moles of Na. If I start with 0.001 moles of OH, I end with 0.001 moles of OH. And now I can take this number and plug it into this equation. POH is equal to the negative log of the concentration of OH molecules. Or, yeah, OH molecule. So let's look how that plays out. So I take the negative log of 0.001, and it's going to equal, well, let's plug it in our calculators. So again, we're going to have 0.001, take the log of that, and then take the negative of that. So the POH equals 3. Now, your question is asking for the pH. So since it's asking for the pH, we're going to take this answer here. We're going to plug it into this equation, that pH plus POH equals 14. So pH plus 3 equals 14. So the pH for this particular solution is 11. All right, I hope that helps. Let me know if you need any other help. You can email me or see me during tutorials on Monday. Have a good weekend. Bye, guys.